Okay, so welcome to 2.7.2 series, right? So last time we talked about sequences. Sequences is a group of terms that follow one to another, and a series is the same group of terms but just added together. So it sums up all the values of a sequence, and this thing is called sigma. And you see it a lot in advanced math, and it might seem condescending, might seem perplexing, but it's not that bad. So here's what a series looks like, right? 3, 7, 11, 50, 19, 23, pretty standard. And this is how you represent it in the sigma, right? So the first terms, a of 1, you put so the first term, a of 1 right here, right? You put as n equals 1. And then you gotta figure out the pattern. So a of 1 is equal to 4n minus 1. When n is equal to 1. Now a of n, so a of 1 is equal to 3. Right, so you gotta figure out the pattern, which a of 1 is equal to 3, a of 2 is equal to 7, a of 3 is equal to 11, right? So n of 1 to 6, the 6 is the last term's number. And the sigma means the sum of. So the sum of the function 4n minus 1 when values of 1 to 6 are put into the function is, and that's basically what it means, right? So just rewind a little bit. What I just said is what it means. The sum of the function 4n minus 1 when values of 1 through 6 are put in and summed when are evaluated and summed together. So the actual answer to this is 78, which you see these small group of numbers, and then you see 78, which is quite big compared to the rest of them. So this summation notation actually goes pretty quickly up as you go on through the series, right? So evaluate starting from 2, the sum of 2 to the n when values from 2 to 5 are put into the equation and summed up. So 2 to the n, 2 squared is 4 plus 8. So now we have 3, right? And then 4, so 16, and then 32. And you add all these together, you will get 60. Okay, so this time it's the sum of absolute value x minus 5 over x minus 2 from terms 3 to 6. So 3, 4, 5 are other terms. So when you put 3 in, you'll get you'll get 2 over 1 plus. Put 4 in, you'll get 1 over 2 plus. You put 5 in, you get 0 plus. You put 6 in, you'll get 1 over 2. So this totals up to 1 over 4. This totals up to 2.75 or 11 over 4. And that's your answer. Next, so we talked about arithmetic sequences last time. Now we're going to talk about the arithmetic series. So it's the exact same thing. There's a constant multiplier, constant difference between the two terms. So it's a linear equation basically. 3, 6, 9, 12, 15, 18, 4, 7, 10, 13, 16, 19, 1 half, 1, 1 and 1 half. They're all arithmetic sequences. Minuses count as well. Right? So if we want to find the first term, and we also want to find the not the multiplier, but like the constant difference, the amount that's added every single time. So we can figure that out by using this formula. So I've deduced the formula for you. an equals a sub 1 plus n minus 1 times k. Right? So every single n minus 1 means the first term doesn't actually get any of the numbers added. The first term just doesn't get anything, right? So a sub n minus a sub 1 is equal to n minus 1 times k. Divide that together. You'll get a formula similar to finding slope. So a sub n minus a sub 1 is over n minus 1 is equal to k. Right? So that's how you find this. And it doesn't have to be a sub 1. It can be a sub 2 or a sub 3 or a sub b, right? So a sub n minus a sub b over n minus b is also equal to k. So in this example, for example, we have a sub 4, which is 16, minus a sub 2, which is 4, right? And then we have our 4 minus 2, so our 16 minus 4 is 12, and then 4 minus 2 is 2, so our constant difference is 6. That's it, simple. And in order to find yourself the sum of the series, you can plug in the terms for the sequence in this form right here. Right, an is the largest number, a1 is the smallest number, and the number of numbers is 8. The number of numbers is this n right here. So a sub 2 is 13 and a sub 4 is 27. Find this. So first thing that we gotta do is find a sub 1. Now how do we find a sub 1? Well, we have the thing right here. So a sub 1 is equal to, a sub 1 is equal to a sub n minus n minus 1 multiplied by k. First we gotta find k. So our formula is 27 minus 13 over 4 minus 2, which is 14 over 2, which is 7. Right? So our k is 7, so 7. And then let's think about what a sub n can be. A sub n really can be anything. It doesn't have to be the largest number of the sequence. So let's make a sub n as this boy here, a sub 4. So we have 27 minus 7 times n minus 1 is 4, so 4 minus 1 is 3. And our k is already figured out. So a sub 1 is equal to 27 minus 7 times 3, which is 6. So we found a sub 1. Now we can plug it back into this equation. So now a sub n equals 1, n starts with 1 and ends with 8. So we want our 8. So that's just equal to, we want our a sub 8. So that's just equal to 8 plus, 8 times, and a sub 1 we know is 6. And a sub n we can figure out by the formula. Add that to the formula of finding a sub n, which is just 6 plus a sub n is equal to a sub 1 plus n minus 1 times k, and a sub 1 is 6, so 6 plus n minus 1 is 8 minus 1, which is 7, multiplied by 7, and then divide all that by 2. So since we have our 8 and we have our 2 right here, we can do 4, and by basic arithmetic, you can figure all of this out yourself. You will get 244. There you go. Next, we have geometric sequences. They're the same as geometric series. They're the same as geometric sequences, but they follow exponential pattern instead. So a sub n is equal to a sub 1 k to the power of n minus 1. So it will be all the exponential equations like a to the x, e to the x, 3 to the x, 10 to the x, 10 to the 1/2 to the x, 3 to the negative x. They all work, right? So this is how you find a multiplier. It looks pretty confusing, but it works, right? So a sub n over a sub 1 is the n minus 1 root of a sub n over a sub 1 is equal to k. So I worked out an example right here already for you. A sub 3 is 64, so 64 over 4 is 16. And then we have our numbers 3 minus 1 is 2. So the second root, or the square root of 16 is 4 or negative 4. Negative 4 in fact actually works, because we can do 4, negative 16, and 64, and it's still a multiplier of negative 4. See, so it's pretty cool. If a sub 3 is 80 and the multiplier is 5, what's a sub 1? So we could just use this formula right here. So a sub n is equal to 8, let's say it's a sub 3, 80, divided by multipliers 5, so 5, and then the n is, well, a sub 3, so 3 minus 1, that's equal to 80 over 25, which is equal to about 3.2. It's exactly 3.2. So if a sub 4 is 60 and a sub 7 is 480, then find find the a root of, from n equals 1 to 9 of a sub n, right? So I forgot to put a formula, but the formula for this one is actually n times, and no, it's actually a sub 1 times r, 1 minus r to the n over 1 minus r. That's the formula, right? So a sub 4 is 60 and a sub 7 480. So with the first formula, let's find what the multiplier is. So 480 minus 480 over 60, and take the square root of that. 7 minus 4 is equal to the cube root of 8, which is equal to 2. So our multiplier is 2. So we know it will be 2tx, right? So we already have our details that our multiplier is 2. But we want to find the first term. So we use the other formula. Let's use a sub 4, for example. 60 over 2 times 60 over 2 times 4 minus 1 is equal to basic arithmetic. I'm not going to work it out for you. It's 7.5, or 60 over 8, which is 7.5. So we figure out our a sub 1 term, which is 7.5. 7.5, multiply that by 1 minus r to the n. And r just means our k. R means k, right? R is the same thing as k. It's a multiplier. 2 to the 9th power over just 1 minus 2. So this is equal to 7.5. Oh god, 7.5 times 511, which is about 6,000. Right? Let's see how much it actually is. It's 15, 30, 15, 30, 60, 120, 240, 480, 960, 1920, 3940, 7980, 7905, 7902.5. That's the sum of the series. So right here, why is this wrong? If a sub n is geometric, a sub 2 is 48, and r is 6. R means multiplier, or k. So we have this formula right here. A sub n is equal to a sub 1 r to the n. They plugged all of this in, right? They plugged all of this in, and then they made a mistake on this part. What's the mistake? Is basic. Actually, no, they didn't make a mistake on this part. What's the mistake? The mistake is they actually used the wrong formula, right? It's supposed to be a sub 1 r to the n minus 1, and there's a reason why there's the n minus 1 is right here. The 2, whenever you plug in a 2, you're only actually multiplying the first term one more time, right? So if you have 6, 12, 24, and you have a sub 1 r to the n, the second term, which is r squared, right? The multiplier is 2, would be 24. It wouldn't be 12, right? You only multiply 2 to 6, 2 from 6 one time. You don't want to multiply it twice. Therefore, when you multiply it one time, it becomes 12. When you multiply it 2 times, it becomes 24. So you have to use the n minus 1 formula, not the n formula. Unless if it tells a sub n equals a sub 0, then you will use r to the n, right? So yeah, this is exactly what I just told you. So the sum of the geometric sequence is denoted as follows: a sub 1 minus k to the n over 1 minus k. And as you can tell, all of these have n minus 1s on them. So we can just do this simply. 1 minus 1 is 0. 0 to 3, that's just 1. So we don't have to have anything here. 1 minus 3/4 to the 7th power over 1 minus 3/4. I think that's the equation. And I can figure out the sum pretty easily. From there, it will just be 1 minus 3/4 to the 7th power divided by 1 minus 3/4. 3.466. That's the approximate sum, because I am not going to give you the exact sum. No way. Oh god, my mouse is defecting, so sorry for the ugly 466. We're gonna do this now. 1 to n. This is just 1 to n, right? So we'll do it, right? This would just be the same thing. 1 minus 5 to the n over -4. Over -4. Yeah, that's it. That seems simple, more simple than is expected, right? So whatever n is, let's say n is 8. That will be a big number, pretty big, but that's the answer. And that's it. Okay, that's it for today's episode. Tomorrow, no, not tomorrow. Next time we'll be viewing on infinite series, and results can really surprise you on how we try to solve infinite series and sequences alike. So see you next time.